Hello, welcome back to the stream, everyone. So yesterday we did quite a lot of tuning for our DQN model. I was expecting to get a decent baseline. I think that was model 30, around 30. So it was doing well at this point, but it turned to completely not doing anything useful afterwards, and you can see the loss start increasing, even though it was decreasing, and then the Q is actually increasing, but not consistently. So it's not something that is doing correctly, I think. So I made a few changes and arrived at this one, which is run number 39. So you can see this one, the loss is much more reasonable. So it keeps decreasing, and then the Q is increasing, kind of. I don't know what this step is, and the reward is actually not decreasing, right? It's not super high, but it's not decreasing. I feel like this is closer to a baseline. But of course, it's not doing that well, right? The reward is not going up, so there's still definitely something wrong here. So let's take a look at what we changed here, right? So I'm not gonna commit all these random things into the Git. I'm just gonna take a look at. Okay, let me actually try to ignore all these things. I think. You know what? Let's just take a look at this. So I added a record of gamma and batch size. That's normal. And then we also record like the ending turn and the turn before that, so that I can take a closer look at what the model is trying to do right before the end. So this is quite useful actually. So I've been running this is the run 39. You can see we can see the log of, for example, this game ended in step 306, and right before that is 305. So you can see in this case, we have some kind of reward here, but the ship count is only 9, and then the next turn it lose all the ship and then it died, right? So we kind of figure out, what went wrong before it died. So I think this is quite useful in tuning the model. And then we also tune the reward quite a lot. I feel like I try to include the ship count into the reward calculation, right? And I try to tune the final reward, give it more reward for winning a game. And then I try to add the ship count to the reward, right? So it takes the current, so my current formula is, it takes the current board reward and logged, and takes the current ship count logged, and then take the ship count delta logged. And so this will be the final reward that it's getting. And now obviously if it wins or lost, then it's just another set of rewards. Winning is 20. Not winning but surviving is 5, and then dying is -20, right? So this is the reward function right now. So those reward functions are giving us this result. Oh, and the other thing I did is to remove the convolution. Remove the convolution layer, because I feel like it's not gonna be very helpful for us to have a convolution layer at this stage, simply because we're encoding the core count of each player into the channel layers, right? And the problem with the channel layer is that it's when you do the convolution 2D, it actually applies to all the channels, so it kind of mess up this information a little bit. So I think I shouldn't apply the convolution if I'm doing encoding these core count in the channel layer. So for now, I've changed the enemy core into a global enemy core. So I'm not counting the individual player core, because I think that's just too much noise if I encode individual players cores. So I'm just gonna get the global enemy core and then calculate it by summing up the core count of all the players. And also remove the XY position because I think our model is not able to comprehend the XY position yet. I feel like even if it had the XY position, it's not gonna be able to like attack or defend, right? Because we haven't coded that. So I remove that to reduce the amount of noise. And this is what we are arriving at. So at run 39. Okay, so the graph looks okay, promising, but the result is not so well. So let's take a closer look at the log and see actually what is not correct. So I feel like that's something I need to take a look at. So first we take a look at the model architecture. 31 times 31 times 7. So 7 is the channel map we have here. So we have 7 channels. The core count, the player flip count, opponent flip ship count. This is per cell. And then shipyard count. This is also on individual cell. And this player core and enemy core is on every single cell. So this is kind of like an alpha layer of the map. And then we have total trainable parameters at 600K, which is okay, I guess. And then let's take a look at this reward thing, right? Reward is very important. So we want it to encourage good rewards for a good thing. So you can see here the reward is pretty standard. There's nothing interesting here. Let's find a game where we actually survived to see if we are giving the reward correctly. Okay, we didn't. So this is where we survived. And we only got a reward of 5. So that's not very good, right? I think we should give more reward when we survive. One idea I can think of is to encode the turn number in the reward. So let's say we can give a reward for reaching turn 300, 350, and 400, right? So this could be something interesting. I can try this. So that it favors, like, you know, surviving for longer turns, something like that. I could also tune up the ship count reward so that it favors more ship. Right? So give more reward for having ships, right? So I think that's something I could do as well. Yeah, so basically this reward is too flat. It's not able to tell a good state from a bad state, right? So everything is just about 10, 15, stuff like that, right? So it's way too flat for you to get any useful information. Yeah, I think that is actually the problem that we have here. Let's take a look at some of the higher reward here. So this one has a very high reward, but it shouldn't, right? It shouldn't have a high reward because your ship count is only 61, so it's very dangerous for you. You shouldn't have that amount of ship reward, right? So definitely we need to add more ship count, give more reward for having a large ship count. So that's something we definitely need to do, right? All right, let's do that and see if that improves our model. Let's see. Let's give a higher reward for surviving because currently it's lower than having a good board, right? So having a good board is like 14 and surviving is only 5. So that's kind of disincentivizing us to survive, which is not very good. Yeah, so let's do that. I think I'm gonna tune up the final reward for 1 to be a little bit higher, like 30, and then give these survive 15. And if it's died, I think minus 20 is fine. Let's keep it consistent to 15. Right, then I want to encode the ship count higher, right? So I'm gonna actually give the ship count higher weight than the reward. Right, so this is the ship count logged. I'm actually gonna give this a higher weight. So ship count delta already has a reward associated, but not the ship count itself. So what I'm gonna do is I'm gonna give this a factor of ship count reward factor, right? So let's call this ship count reward factor. I'm gonna use the same terminology here because I think this is a terminology I used in my previous game, right? So I'm gonna get the reward factor, maybe core reward factor is gonna be 1, and the ship count reward factor is gonna be 2, and ship count delta reward factor is also gonna be 1. Right, so this is if I multiply this with the factor, it's gonna give us more weightage towards the ship count. Right, so it should theoretically, after I make this change, it's gonna favor building ships over collecting core, stuff like that. So maybe we need to tune this a little bit down later. So this is the final reward equation that I'm arriving at. I also want to so let's mark this as done. I also want to encode the turn number. We actually already done this for the ships, not for the shipyard. So we've done this for the ships. We give a small reward for building ships already. So we can put that as done. Yeah, we also didn't log to the end reward already, so that's also done. We need to encode the turn number, so I think that's quite important. That is quite important actually. Let's see. Do we have the step information here? I guess we could just take the step, the I as a step, right? I think we can just take the I as a step. Turn reward factor. Right, so we need to give some reward to the turn, right? Let's say, for example, is 400 and okay, so let turn reward turn number, right? So not turn number. We need to incentivize it to survive longer, or maybe even before, like at least in the beginning, before it starts to eliminate other people. Turn number reward, right? If I equal to 0, then turn number reward is 1. Hihaku probably is trying, but okay, it's not very good, right? This is gonna stop. It's not very good at this. Okay. If I is equal or greater than 380, we want to give a reward, right? For surviving this long. Let's give it a 3. Else, if I is greater or equal to 350, can give it a 2. I is greater or equal to 300, let's give it a 1. So I feel like this is something reasonable. We could tune these numbers. And I'm gonna add these numbers to the formula, right? So this is our final formula. Looking pretty good. Let's move. Let's make our logging also better. So we have action, state, reward, final R. And ship delta or reward delta, reward. Where's the reward delta? I guess we don't have the reward delta. Yeah, we don't have the reward delta anymore. So let's just log the reward log. do we have the ship count log? Ship count delta reward. Okay, so let's do this more carefully. Reward log, ship count log, right? So we need a ship count log. Ship count log. I want to print all these things so that we can analyze them. Ship count log and then ship delta reward log. Ship count log. Ship count. We can keep this for now. Okay, so we need the log ship count delta. So it's getting more and more complicated. I feel like we're already over-engineering a little bit. Turn number reward. Turn number reward. Right. So code it here so that we know exactly what we're adding into the formula. Right. So we have the reward log, ship delta reward, and turn reward. So these are the things that we care about, I think. Yeah, I think this looks good. Oh, the other thing is I want to remove the core count from the map as well, because I think that's not very useful information. It's just noise, right? I might need to remove the core count from the map, from the state. Remove core count from state tensor. So this is something I think I want to try. I think this should give us a decent baseline already, hopefully. So let's try this out. We're gonna run this as the run 40. Yeah, let's see how this works. Oh, we won our first game. Interesting, just completely random. Oh, wait, there's a none here. Okay, that's something definitely is wrong. Let's play one more episode before we terminate this. Yeah, there's a none here, so the log ship count is none. The second one here, so that's the log reward. It's none. Okay, log reward is okay. Okay, I need to Google JS log to negative number. Okay. So we need to log the absolute number and then multiply by something, I guess. How do I do this? negative mass dot absolute reward +1 log2 minus, I think this should be correct. Hopefully this will remove the nuns. Okay. Oh wait, this has 26 and this is only 15. Because we gave the weight 2. Right, so that's something to take note. I think we might be given too much weight to that. Right, so the 2 might be a little bit too much, I feel like. It's causing the reward to go up too fast. Or maybe we just need to give more rewards to the final rewards. Okay, let's do this. Const win reward. Go to maybe 100 is fine, I guess. Lose reward is minus 1500. I don't know about that. We'll see how it works. Survive. Reward is 50. Okay, seems fair. Seems fair, right? This seems to be fair. 100, so that we don't, end up where the winning a game can yield less reward than having a ship. Right? So that's something we need to take care of. All right, I think this should be good. Let's try to run again. Okay, now it's negative 100. Okay. Reward, ship count reward is 0, so log reward, log ship count. Wait, why is log ship count 0? Something wrong here. Log ship count is not doing correctly. Oh, ship count delta. Oh, we forgot about the ship count log. Okay. Let's see. There are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, seems to be correct. Let's just move the reward to outside. I think reward is in a different category from other things, right? Because it's not used in the final reward computation. So let's remove that. And these are the factors that influence the final reward calculation. So let's put that there, right? We can even put the final reward here. Final reward here, right? So that they can check them together. Okay, let's stop this and restart the training. Ship count reward. Okay, looking good, ship count. Okay, so this is the log. This is the log reward. Log. This is the log ship count. Log ship count delta. And turn number reward. Right. Turn number reward is going up. You can see here. So it's doing what I expected to do. Let's observe this to see if it's working correctly. So this one survive very long. It should have a higher reward, right? But it doesn't have a lot of ships, so it's quite low. Okay, so this one has a very high reward, right? Yeah, so this one has a high reward. So it's doing what I expected to do, I think. So this one almost survived, right? So this is a good example of almost good, but not quite yet. I feel like we need to maintain a minimum number of ships, or a ratio between number of ships and the number of cores, so that we don't like mine too much and die. But that's like already a very cheating way of optimizing this already. So I don't really want to do that yet. All right, let's keep this going on for a while. I'll take a break and come back to check the progress. I will leave this on in a tensor board so that we can check the progress. So 39 is the previous almost baseline run, and then 42 is what we are running now. So hopefully this is gonna be better than the previous run. Let's see. I'll be back in about 10 minutes. Okay, we're back. Let's see how well this model is doing. Okay, so this is looking quite interesting. The loss started to increase, but then it's also started decreasing. I think this is quite normal at the beginning of the training. Q is not doing so well though. Q is like going down and then now starting to go up. And the reward is very, very low. We haven't even won a single game yet. Let's see. Let's take a closer look at how this is going. Maybe it haven't explored sufficiently to reach a game where it won. Yeah, I haven't won a single game. I don't know why is that the case. Is it choosing actions that are not very good? So I think, for example, in this case, it's keep choosing action 3, but the final reward is actually 17. So it's not disincentivized to take that action. So we might have to give a penalty for no action. Right? So we might have to give penalty for no change in board state, invalid action. Right? So this will prevent it from taking action that is because the problem with encoding current state as action is that even if you don't take action, you still get the reward. So it's kind of hard to learn that you need to take an action. Right, so I guess that's the problem that we have here. Can we find the case where it actually learned? Let's see. Okay, so here's a case where it actually built something. So it's actually being rewarded for doing that. So it should actually pick up. It should actually pick this up as a learning point, right? So it went from 18 to 25. So it should learn that, when you have enough core, you should start building ships so that, the ship count increases and you are being rewarded for building a ship, right? And the reward jump from 18 to 25. So that's something we should encourage. And it's actually encouraging that, but it's still not doing very well. It's not even winning a single game yet. So maybe it's just too much randomness that's causing it to not win. Maybe it's something else. We have to, keep monitoring to check what is going on. Another useful matrix to monitor is the number of steps that we reach, right? So maybe it's getting better at reaching the end game. So that's something we should also do. Track the number of turns that a game has reached to see if we how long we survive. Right? So ideally we should be surviving longer and longer until we encode the attack strategy, of course. So once we are into the attack strategy, we should be aiming to finish the game early as possible. That's for later. Right? So you can see this game we actually won. So it got 21 as the reward before we won. So that's actually pretty good, right? So it's actually trying to win. In this case, it's 18 and not winning, right? So we kind of have to build ships. I hope it figure out that we need to build ships to win. That's a goal here. And you might notice that there are a lot of, these kind of things where it doesn't really change anything. So that's something we actually want to avoid putting into our replay memory. Because that's gonna just be noise, right? Not signal for training. So we need to filter out the inactions, right? So sample, so filter out invalid actions from replay memory. Maybe sample invalid slash maybe maybe repeated action is a better word, right? Because for this kind of thing is actually repeated, right? So this is an example of what we want to filter out. This is pretty useless. It just takes up our replay memory. Yeah, I think that's a good strategy to have. So okay, now it's starting to win games. Hopefully more and more games. This is a pretty bad example. Doesn't even have any ships on this turn. It's pretty much dead, right? It doesn't try to build ships though. It's quite weird. It's not trying to build ships. I got a feeling that it's gonna yield us a decent baseline based on the current trajectory that this is going. I feel like it's has a decent chance of giving us a baseline. Okay, baseline is interesting. It doesn't have any shape, but it's somehow supposed to manage to win regardless, which is interesting. I wonder what happened in that game. Oh wow, there's another game where we won without a single ship. Huh, how is it managing to do that? That's quite interesting. I didn't expect this to happen. And it's happening consecutively. I guess the enemies are not powerful enough to kill this. So that's the only explanation I have. Or maybe we should lock the shipyard count as well. Okay, we need to lock the shipyard count. Monitor shipyard count. So that we know, how many shipyards we have. Yeah. Potentially encode the shipyard into the reward, right? So this is something we can do. I need to sample this, what we add into the replay memory. I feel like we're adding too much useless things into the replay memory at this stage. All these things are just not very useful, right? It's just noise that is not helping at all, right? So I'm curious if at this form is able to generate a baseline for us. I'm really hoping to get a baseline before we do any sort of experimentation. But it seems like we're not getting there. Right? This is not doing as well as I would like it to be. The queue is not actually increasing. So I guess it's time to stop this and try something else. Yeah, let's try to sample the try to sample the what we add into the replay memory, right? So that we don't clog up all the replay memory. You can see here we're actually adding, about 400 in each game, right? So ideally, after we do the sampling, it should be less that we add into the replay memory. Something like that. Okay, let's stop this. I think this is not going very well. First, I think we need to make sure that we only train when we have enough in replay memory. So let's change that. If frame session count. Okay. I think we can move this here. So we can do a plus here instead of doing it there, so that we can only add, we have this, and this we can change this to start training size, right? The training size is 46 times 2. I think we can afford to go higher a bit. 256, okay, I think that's fine. I don't want to train like on weird data. Okay, so now we've taken care of the training stuff. We should start to, okay, we don't need this anymore. Train agent, train count. Okay. We don't, now that we do this, we just need to add the replay memory with sampling. Okay, we'll do like a sample here. Let's sample step equal to true. And sample step. Action, reward, stuff, blah, blah, blah. This is very, very long. Can I break this down to, okay, I can't. Oh, that's interesting. 20, let's change this to maybe 80 so that it starts to break this down. Okay, 80 is a little bit too much, maybe 110. Okay, 110, it doesn't try to break it down. Okay, whatever, that's fine. So that's the done and sample the sample step. Sample done. Okay, so I think that's fine. That's fine, everything is fine here. Let's actually do the sample logic. So I think it's pretty simple to write this, right? If the state is exactly the same, then we don't sample, right? So, oh, we can actually check the next board. Do we actually use an export? No, we don't. Okay. Current board. Ship count. I guess if the ship count and the reward is the same, then we sample, right? I think that's the logic here. Let me check if the reward and the ship count is the same. Yeah, definitely sounds like that's the correct logic. Previous reward, previous ship count. Okay, so we already have this, right? I forgot why we had this, but I think this is quite useful. We have previous ship count. Oh, it's to calculate the delta and the reward. Okay. Oh, we already have the delta, so we could just take the delta and check. Right. Yeah. We could just take the delta. Decide if we want to sample this step. If delta and ship count delta sample step equal to false. Okay. Kaggle Copilot is pretty smart. Okay, let's move this above the logging. Log step information. Okay, this is getting pretty long. We might need to refactor this after we reach a baseline. Now, the most important thing is to get a baseline. If we don't have a baseline, there's nothing to talk about. We cannot progress at all if you don't get a stable baseline to start this. Okay, I've got a feeling that this is gonna work. I've said this 43 times already. Hopefully this is the one. This is a run. Hopefully this is the run that is gonna give us a good baseline. Let's see, sample equal to true. Okay, that's not a good sign at all. Oh, sample equal to false. Okay, so that's good. That's good. We only had 64 memory. Okay, that's good. Oh wait, maybe that's too much. Wait, why is the loss none? Oh, because it haven't started to train. Okay, makes sense. Makes sense. It's always choosing 3. Okay. After 3, 5, 6, it should start getting lost, right? Yes, that's correct. The Q value is increasing. Why do we already have Q value? That's quite strange. I would expect us to not have Q value. Okay, maybe completely not sampling it is a bad idea. Maybe it's a bad idea to not at all. It should still be added at a certain frequency. Otherwise, it's just gonna take way too long to fill up the replay memory to something that is meaningful. Let's observe for a few more runs before we make a decision. So far, it's going good. We are completely avoiding the runs that the turns that didn't do anything. I feel like that's a very risky thing to do. We should still add it with a probability of maybe like 10% or 1%, something like that. Not completely avoiding it. The good thing is the loss is kind of working. It's going down. I don't feel like this is the correct move because we're building up the replay memory to way too slowly. Let's check the graph. These are none. I think that's fine to have none in the beginning. It's fine. It doesn't really matter. Okay, so this graph is looking really good. I guess that's the same for other graphs, other runs as well. At the beginning, it's going up. Okay, I'm gonna give it a few more minutes before I decide whether I should add more samples. I think this is too aggressive. It's gonna miss out a lot of empty states. That's what I think is happening. So every single data point now is a good data point. But I think there needs to be also like the normal data points to fill the gap. If it's only good data points, then it's gonna learn too fast and go to like extremes, bouncing back and forth. I feel like that's the idea that I have right now. But the graph is actually not that bad, right? The graph is actually not that bad. It's just that we have very few data points to train on at this stage. Might take us too long to observe, that it's not doing well. I feel like I should probably just stop it right now you can see we're not winning any games. Yep, I think I'm gonna stop it right here. Yeah, it's too aggressive to not put it into the replay memory at all, so I need to have a probability. So we have a 90% chance of not sampling, or maybe a 80% chance of not sampling. 20% chance of sampling it. I'll cut us 1/5, 400 turns divided by 5 is 80 turns of random data. Maybe that's too much, 0.1. I think that's gonna do it. Hopefully. 44. Okay, let's go. Number 44. So now we should be filling up our replay memory much faster. 40, at least 40 replay memory for each episode, right? So you can see how here we got 46, and some of it is getting saved, right? At least this one is getting saved. This one is getting saved. Okay. So this should allow us to build up the replay memory much faster. As compared to the previous one. So it should start producing loss also faster. I think it should start producing loss right about now. Yes. Okay, and the loss is lower, which is good. Okay, that's pretty good. So the loss is actually lower. That's probably an indication that we're doing something correctly. The Q is also much lower. Why is that the case? Why is the Q much lower? Not entirely sure why it is much lower. It should be higher than this. It should be a bit higher than 1.8. It's not sampling this one. Okay. Oh, it's not sampling the states where it's stable. That's why the Q is actually low. Is that a problem? Maybe not a problem yet. Maybe it's not a problem yet. Maybe it's not a problem. I don't really know, but let's see how it works first. I think 39 was our best shot. We need to take a look at the latest one. I think we're training much more aggressively than we should have. Yeah, that's probably a problem. We're training too much. I feel like we're only adding 40 and we're training 20 times on those. So it's not very good training data to have. But it should get better over time. At the initially it might train on very bad data, but it should get better. So this is better than this. Okay, so that makes sense. Having 58 ships is better than having 18 ships but more core, right? So I think that makes sense. So it should be learning the correct thing, I think. It's definitely should be learning the correct thing, or at least the correct thing is in its replay memory for it to learn. Whether it learns from them is a separate story of sampling. Okay, this one actually won, so it got here without having too many ships though. I guess it needs to learn that it need to conserve ship, not send them out. I guess that's the lesson here. That it needs to learn somehow to maintain a number of ships. And this is a very bad example of not building ships. And it was hit with a negative roll. I almost feel like we should have a penalty for not having ships. But that would be like cheating, right? Kind of, you're already telling the model what is good, what is not good. I feel like it's a little bit cheating. Try not to do it. I think having reward for having a large amount of ship is already good enough. For example, this case, we're already incentivizing to build ship, right? So it should theoretically teach it to build ships. Actually, I'm not seeing a lot of action tool. Not a lot of action tool here. Action 2 is actually pretty important. It's building the ship. So not a lot of action 2 in the latest training. Actually, there's no action 2 at all. Oh, that's quite strange. That is quite strange. We don't have action 2. It's always 1 and 3. Okay, now there is the action 2. So this should be encouraged, right? Yeah, it is encouraged. But only encouraged for 1 round. And then it sends it out to my more core. Okay, let's check the graph. So actually, this is a very nice Q-learning graph, DQN learning graph. As far as the trajectory goes, so we have a loss that is going down gradually, and the Q that is going up. So this two looks very good, very correct, like correct graph. Reward is also okay. I guess it's starting to win some games, which is promising, but this is too early to tell. I think overall this is on track to becoming a good baseline. Definitely better than the previous attempts, I feel like, because I think all the numbers are making sense. What are the correct rewards, stuff like that. It's definitely making sense. We can make more tweaks here and there, but I think this is good enough for now. We've did the sample repeated action already, so let's move this to down column. And we did something similar. Track. Okay, we haven't done this. We haven't done this. Key penalty to no change. We didn't do this. Okay, so we can park this one later because we are already done the sampling. Okay, so these are some other ideas we could try to get a baseline, but I think this should be enough to get us a good baseline to work with, right? So hopefully this is gonna produce a good result. I think I'm just gonna let this run, keep running for like a few hours until it's like, unless it's not doing something correctly, right? So I'm gonna let it run maybe 500 episodes and see how it works. All right, I think that's all I want to do for this stream, and I think I will continue streaming at the end later today. Let me check my schedule. I think I should be able to stream later today. Yeah, at night I should be able to continue streaming. Okay, I will let you guys know how this round turns out. It's round 44. So we'll come back to look at this graph in a few hours. Okay. So far looking pretty good. I'm not gonna lie. All right, that's all.